Good morning. Welcome to 2020 Engineering Forum. Commodore Durbin, thank you for attending this morning. Out there in the rest of the community, I'd like to begin with a welcome to country. I'd like to begin by acknowledging the traditional custodians of the land and sea on which we gather today, and pay my respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Islanders peoples here today and those who have served our Navy. Today's program is being conducted through a variety of mediums. The interactive components will be conducted over GovTeams. The whole event is being streamed on YouTube, and there's supporting material, presentations, etc. available on the DPN Fleet Engineering website. Before we get started, I'd like to acknowledge the efforts of everyone who's come together to support this event, my staff and the facilitators in the locations around the country. The theme of this year's forum is Enable, specifically in relation to the engineering motto of enabling capability. Today's program has presentations by some of our most junior members of the community and senior officers. It represents, in part, a range of the activities that our community has been involved in this year. And what a year. So why have a forum at this time? There are two reasons that come to mind. Firstly, we're all technicians and engineers, and we have a desire to improve what we do. So in this, we need to review the progress to date and find out what worked and what didn't work, and put that into the plan for next year. Another reason is that we're all social animals, and this year has constrained the development and maintenance of our relationships across the community. We haven't been able to travel, we haven't been able to gather in bigger groups. So although we're gathered around the country today in smaller groups within state COVID restrictions, there's still value in coming together and having a discussion. So in the breaks that we have today, I encourage you to do that. In the major locations where we're streaming this event, we have refreshments provided by Navy canteens, and I thank them for their contribution. And please remember that all profits in the Navy canteens go back to our Navy family. Okay, so onto the program. Our first presentation is by leading seaman MT Gonzalez, who participated in the Penske Power Systems outplacement program in 2018. This is a recorded presentation about how he used the skills he learnt in that outplacement program to deliver capability. Thank you very much, and I hope you enjoy the events today.
G'day, I'm leading Seaman Gonzalez. I've been asked to speak today to the Fleet Engineering Forum about my experience with an industry outplacement. In 2018, I did an industry outplacement with Penske Power Systems. The reason why I applied for the outplacement was in 2011 I conducted an ASTC, being milling and turning. Since completing the ASTC in May 2011, I'm still yet to use a lathe or a mill for anything other than a coffee table for my day-to-day job. So the training I got on that course wasn't relevant at all to anything I've done since completing the course. In 2017, I was posted to HMAS Toowoomba in MEO1 as a propulsion systems maintainer. I had concerns with, I raised the concern, with my divisional staff that the training I'd got from the Navy wasn't really relevant to the position I was in, and I was seeking a way to remedy that and get some training that would help me. My concern being that if any concerns or challenges arose, such as a breakdown in an engine, I would struggle to contribute due to my lack of base knowledge of the engines and systems I was working on. As such, my DMEO at the time recommended I apply for the Penske outplacement, which was commencing in 2018. AGs as well, so again the AG prime movers. I spent about 5 months at the learning how internals of an engine and then how to best clean it and remanufacture it as required. On the completion of my outplacement in March into HMAS Toowoomba, back into my old rack in fact. We conducted workups and prepared to go to Asia. Pretty early in the trip, our starboard, port propulsion diesel engine suffered a failure of one of the intercoolers, the seawater intercoolers, and it leaked salt water in through the B-bank side of the engine. We found that just seeing the exhaust temperatures all low on that particular bank. What I was able to map over from the training at Penske was how quickly we were able to strip down the engine, find the problem, and not only the problem, but also all the damage that had been done. Once we got back into port, we were well aware of all the damage that had been done, and we were able to better preserve the engine, preserve the cylinders with a mixture of diesel and lube oil to stop the salt water that had ingressed into the cylinders from causing any rust or any damage in the cylinders. But we also were better able to explain to Penske what was wrong with the engine so we could expedite the repair. Later on, after completing that particular deployment to Asia, we began workups to go to the Gulf in the start of 2020. And mostly the work I was doing there was operator maintenance, so oil changes, filter changes, all the basics. We had 3 cold cylinders on starboard PDE, which we did our investigations through injector changes. We did injector changes, that didn't work. We did pump changes, that didn't work. We went through various sensors, and so we started to look a bit deeper, and we were able to find that the camshaft for the A-bank on Star PD had suffered a failure. So that was putting the timing off for those 3 cylinders. And where the Penske training, the training I got from Penske really helped me was I was able to strip the engine apart with only myself and 1 or 2 of the ABs. And we didn't lose any parts, which was a big bonus, but we were able to stage it, to strip it and rebuild it as efficiently as we could. We rebuilt the engines because we didn't have a spare camshaft on hand, and we started it up just to prove we could for an emergency and waited for contractor support pretty much. Penske sent out their technicians about a few weeks later, and we stripped the engine down, and we had the engine ready to receive to take the old camshaft out and put the new ones in before the contractor had got on board, which was a credit to the MEO1 department on board Toowoomba. In the end, it only took us 3 days to change out the camshaft, but the team themselves and the people who are running the outplacement will help you out best they can, because you've shown that you want to be there and you want to learn, and that's the best advice I can give to it. And that's all I've got to say. Thank you very much for listening.
Okay, so I guess you get from that, despite the glitches, that the experience for Liam Simon Gonzalez was actually powerful. It was something where he was able to upskill, and something I think people need, especially the junior sailors, be aware of what opportunities there are. That was only one example. There's a whole lot of stuff going on in the background, and so especially for the WEs as well, there's opportunities for outplacements there. So keep your eyes and ears out for those opportunities. At the end of the day, we've entered a relationship with companies and other industry partners for the next 30 plus years. We need to understand how they work. They need to understand how we work. Having these industry outplacements is a way in which we can actually do that. Okay, moving on to the next one. Come on. I'm really proud to be able to present this group of people. So since being in the seat, I've always wanted the technical community to be able to claw back our corporate knowledge. Things where a lot of the industry partners have taken on certain jobs. Some of our corporate knowledge has disappeared, and a part of FSU, or the Combat System Alignment Cell, has been able to actually start the process of getting this knowledge back. It's also a way in which we can actually increase their technical mastery, and it provides meaningful work, and more importantly, it actually empowers our sailors. It allows them to actually do their jobs. So this cell is fairly new. I'll get Warrant Officer McLean to actually take you through it, so please enjoy.
All right, good morning, ma'am, sirs, and the rest of the naval engineering community that are all watching today. I'm Lenny Simon-Oliver. I'm one of the Calics down at the Fleet Sport Unit Fire Control Section. Just quickly run through the team here. We got Able Seaman Mark Bowler, sitting there. Yep, Able Seaman Trent Maguire, and Seaman Alan Cleland over there in the corner. So we're just going to quickly run through what we do as in combat system alignments on board the ships. We've brought up some of the gear. We'll have a quick run through of all that, and the boys are going to go through some of their experiences and what they've learned through this process. It's been a bit of a learning process for all of us. So I believe we're starting with Able Seaman Bowler. So take it away, Mark.
Thank you very much. Ma'am, sirs, good morning everybody. My name's Mark Bowler. I'm a gun weapon system maintainer on DDGs and Speak 9 Bravo, and I've been posted to FSU for about 12 months at this stage, just as we've come to this, well, we're moving along now with the embryonic stage of our combat system alignment getting up and running. I guess for FSU, what this means is increases our capability to support the fleet, which is by definition what FSU is meant to do. It also increases the skill sets of sailors like myself, that we have meaningful work while we are not posted to a ship. Personally, it's given me an appreciation for my actual normal job role as a gun weapon system maintainer as to why alignments are done and what it actually means for my job when adjustments need to be made. So the combat system in itself is a very complicated system, I guess, because there's so many different components to it, whether it be guns, radars, all the electronic individual systems that all get brought together. So as an alignment team, what are we doing? Well, as a general rule, all those different components need to know where they are in reference to each other on a ship. So if you can think of an example, like a radar's up sitting on top of the mast, and that may be targeting or just surveying something out in the water, but it needs to know the difference between where that is and where the actual gun is in relation to each other. So if a firing solution is required, it can be performed. So this obviously has to be done periodically, as along with if any major works have been done on the ship or replacement or new installations have been performed. So I'm just going to briefly walk you through our first piece of equipment here, and so it's going to be a very general overview, but as to what it is that we do. So here we have an analog inclination data system. It has an acronym like everything else in the Navy. We love acronyms. It's called an AIDS box. The US Navy came up with that one. What does this do? We have a master reference on board a ship that everything else is referenced to. So that's obviously not only its location, but also the plane that it sits on. If you imagine, looks like we've got surveying gear and that sort of stuff, out in the civilian world, everything is referenced to gravity and perpendicular to it. On a ship, that may not quite be the case. Our plane that we're referencing to isn't referenced to gravity, it's referenced to something on the ship, because the ship may not always be sitting in the same position depending on ballast, its list, whatever else, so it just needs to know in reference to that. So what this basically does is our master reference, or a point on the ship that all ships are different, that we decide. We have two different style of accelerometers. So basically what they do is they tell you, it's like an electronic level, I guess, and that tells you what that master reference is and what that angle is. Then when we go to whatever piece of equipment that we're utilising, we might supply this one, and by cross-referencing the two different accelerometers, we can find out what the difference is between it. Now that difference maybe just need to be recorded, or sometimes we can use that data in order to enable corrections to be made. I guess, yeah, I mean, it's a very basic piece of equipment, I suppose, in one respect, but the data that we can gain from it can be very important because ships can move and change, and we need to actually be able to account for that. So with that, I'll hand over to Abelson Maguire, and he's going to run you through another piece of equipment.
Thanks, AV Bowler. I'm Abelson Maguire and I'm a seaweed maintainer. So I've been at FSU for the last 2 years now, and over the last 4 months I've been involved with fuel alignment jobs on the ship. We've been involved with the installation of the Sydney Quality of Life recently. We were on Adelaide installing NOLCA. We assisted BAE with NOLCA installation, and we're also involved with the Parramatta Combat System Alone. So I'm going to talk about this piece of equipment here. So this is a field light, and the main purpose of our field light, well, minor thing is we can use it for multiple things, but you can actually find the ship's centerline on the ship. You can also pass the ship's centerline to other instruments, and we can also use the laser to create planes. So the first thing we do when setting up the field light is we just set out the legs, and then we get a rough level to the ship's reference plate, which is what Mark explained about the sensor on the reference plate. So with this, we get a rough overview, and then we get it within a certain tolerance. So then what we do is we'd find the actual centerline. So the way we do this is we'd set out a ruler on the ship's centerline reference plates, and by constant adjustments, we can actually find the ship's centerline. Once we find the ship's centerline with our field light, we can actually set up a field light anywhere else on the ship that this can see, and we can actually pass the line to that field light. That field light then knows where the ship's centerline is by using this field light. So another thing we do, we've got this sensor, which is what actually helps us get the reference point from the ship. But we've also, so obviously the Leica, when we first got it, it didn't have this blue bracket here. We actually talked to the Innovation Centre. We designed this. We talked to the Innovation Centre, and they obviously 3D printed it. We put out specs. We've had obviously they don't come out perfect, so we've got to level this as well to 0. And then now we've got the sensor, which can be leveled to the ship's reference plate. And we've also got this bar here, which is what holds an SMR. So we can actually use this field light to create a plane, because obviously you can't see the ship's reference point from where we are measuring on the ship. So we have this plane here. We can create a plane which is a representation of the ship's WCRP, which is Weapons Control Reference Point, and then we can take all our measurements from there. So I'd like to pass it on now to Steve McClellan.
Thanks, David McGuire. I'm Stephen McClelland. I've been with FSU for about 7 months now, 4 of which were spent on COVID, which was unfortunate, but it is what it is. So I'm completely untrained, but in the short time I've had at FSU, I have got to use the Faro Vantage S laser, which is a really fancy piece of kit. It comes with these spherical mounted reflectors, which, if you can see, the laser can track, which is super cool to watch. I'll just put it like that. Yeah, it's gone. It's a class 1 laser, so it's completely safe, generally, unless you look at it through some kind of magnifying glass. And what we do with it is, using generally these theodolites, we can force it to track onto the SMR. Could you just flip that one around? Using the software that comes with the laser. Which is not working. Fair enough. So far we've used it on, in my experience only, the LHDs, and we had it mounted at a certain point, and we could use the data from this from the SMRs. So we would align it to the SMR and get reference planes for what we were installing, which was, as mentioned, NOLCA and other kit, which was the Advanced Stabilized Bioscope Indicator on the LHD. And what we did is using the inclinometer, we set it to the ship's reference, and then we managed to get more reference again through the laser. And using the programming, we can create lines and planes which we can use to see if things are off center. We can rotate it, we can get the X, Y, and Z of it, and generally just compile a good picture of what we're installing and how accurately we've installed it, and whether we can make corrections. As you saw, if we need to make corrections, we can move the SMR and the laser can track it, and just easy as that. It's a really great piece of kit. We could also use it on other ships for things such as mast alignments, or making sure radar plates are remaining flat after going through difficult weather, I guess. There's other uses, but that's beyond my pay grade, really. So I'm going to hand over to Warren Officer McLean now.
I'm Warren Officer Saul McLean. I'm the Deputy Production Manager at FSU Southeast. By way of background, my previous position was the Combat System Alignment Specialist position over in San Diego. This year, COVID has presented a range of opportunities for FSU, and we've really tried to harness all of those opportunities. And the DDG SPO early on in the year invested in FSU, which we thank greatly, and they've given us the equipment that we need to build capacity in the maintenance environment. From my perspective, my experience overseas, what I've seen is the ability for learning these skills and how they translate into sailors understanding how to do different levels of maintenance in the waterfront sustainment environment. And certainly this year, the guys at Southeast have learned a lot of new skills and new methods of doing things. And that's been really pleasing for me and certainly the management team at FSU Southeast. We would definitely like to advertise the skills and advertise the ability to do things. We'd like to work with Navy and with industry on a continued basis to try and ensure that this is a continued capability for Navy, so we can build skills for our sailors in the fleet. The interesting thing with combat systems alignment is translational. So whilst we use this for combat systems stuff, we could actually use it for other things as well in the ME environment, and probably even the AT environment as well. So if anyone's interested, please feel free to contact me at FSU Southeast, and we're more than happy to come and showcase the equipment to your organisation at any time in the future. So I'd like to thank these guys for their presentation on the equipment that they've presented. I'd like to open the floor for any questions that anyone might have in relation to alignment or any areas that weren't necessarily clear to people.
Just a quick one on that innovation there.
Yep.
Do the contractors, have they got that innovation as well, or is that new just to us?
So we with regard to that, they when you buy this commercial off-the-shelf equipment, they don't necessarily build this equipment so you use it on ships more generally. So sometimes you've got to abridge your equipment to make sure you can fit it to use in the at-sea environment. So from what I remember, when we were working with contractors, they also have made some amendments to their equipment as well. Be that internal amendments, actually internal sensors in the system, or manufacturing or fabricating new handles or sensor mounting plates and those kinds of things. So I have seen industry have used different methods to achieve the same outcome, essentially. And this is really principles focused. So providing for the fact that you test and whatever you install, you test that to gravity, make sure that it works at gravity, then when you use it on the ship, you have a known outcome. Yeah.
How's the training, the sustainment of the training? So obviously these guys are from FSU,
Yep.
And they're doing the training here.
Yep.
But how do you intend to roll that out across So ETs get trained in this and they come to a position and we sustain it for long term all around the country.
You know, when I was over in the US, the US model is on-the-job training, and it is just on-the-job training. So they are very process-driven. So provided their processes are good, they trust in the process factor. I don't share that aspect. So I've actually asked for the DDG SPO to get specifically for the laser, because that is what we use it for, is probably 1/5 of what you could actually use it for. And I've done some work with some of the contractors in relation to that, and there is a lot of different potential for this particular piece of equipment. So like welding, we don't necessarily train welding that well. So what I'd like to do is put in a funding line, a yearly funding line. So people who come to FSU, they get some training at the start of the year, or we do them start mid-year, whatever it may be. But basically, we put that training into the program to make sure that can be a continued capability for Navy. And hopefully, you know, people go on that training and they see the laser being used in a particular way, and they think, you know what, I reckon I could use that in a different way to what we're using at the moment, but I might be able to achieve another activity by using the laser that I may not have been able to do previously with other pieces of equipment like theodolites. So a good example of that would be something like deck breakage measurements. We haven't really got a great process on that, and that's kind of fallen by the wayside. But that laser is a shipbuilding grade piece of equipment, so it's looking at hull structure. So you could definitely use that for doing a set of measurements for deck breakages.
So do you ring fencing or something you call them, and you actually hold these people at FSU rather than have them posted?
Yeah, that is the FSU conundrum. Unfortunately, the ring fencing is we would try and ring fence certain positions, but the reality, we haven't actually looked at that part of it yet. Not for combat systems alignment. For other elements, yes, certainly, circuit card repair, but we haven't necessarily looked at ring fencing anyone at this point. Yeah. Any other questions? Additionally, there's actually a combat systems alignment video on the DPN on the Fleet Engineering Forum website. So if you would like to know more, you can consult the website. Alternatively, please reach out to myself or my team at FSU Southeast. Thank you for your time.
Great, thanks Saul. Thank you for your team, absolutely fantastic. Like I said, this is an emerging capability, but one which is really important to us. So it's great to see that it's started, and I'm sure the FSU ED will also talk about what's happening in the future. Moving on in the future, as you know, we are in a really exciting stage. We have a whole lot of capability coming online. With this capability, though, it means we need to work smart, we need to be well managed, well led, but more importantly, we need to innovate. The way in which we do things needs to change as well. An example of this is with our next person, which is a presentation with Leading Seaman A.T. Price. Leading Seaman A.T. Price, through the Fleet Air Arms Shark Tank Innovation Management Program, slips off the tongue, was basically a competition to see ways in which we can do things better, which is what we should be doing. His concept actually replaced a protective face mask and filter system with a positive airflow hood. The positive airflow hood is a reusable item that is effective against all hazardous respiratory substances, negating the need to replace and discard filters. With positive airflow, the design is also effective for personnel with facial hair or latex allergies. Over the long term, the positive airflow hood will reduce cost and improve safety. So let's have a look and see what he has to say and see an example of innovation.
So the air doctor system is a positive airflow breathing apparatus that can be used on board ships and at the squadron, regardless of where you plug the device into. It will provide you with positive clean breathing air that can be used with any hazardous vapour or chemical. Well, initially myself and Leading Seaman Watson were working in tool control, and we just saw the extra work that was required to identify what PPE was required with certain chemicals. We did some research and found that using positive airflow breathing apparatus was fit for purpose regardless of what chemical you're using. So we went down the avenue of looking at a device that we could implement that would best suit our working environment. So we came with an idea of obviously positive airflow breathing apparatus with a full hood. We approached a number of companies, didn't really have what we were looking for. We spoke to the air doctor in Sydney, and he had a number of options that we then put into a new kind of unit that was suited to our working environment. We then pitched that idea at the Shark Tank, and they liked the idea, and it was pushed from there through FAA HQ. Once we went to Shark Tank, we were involved, I guess, to provide information and how best it could be used throughout the fleet air arm and on board ships. But from that point, it was more through FAA HQ and NASPO to deal with the procurement of the item and bring it into service. I guess putting our presentation together and presenting to Shark Tank, to the Commodore and a number of other CEOs of the squadrons was a pretty good milestone to see the hard work that we put in was taken on board and seen in good light. So it was good to see the hard work there paid off. And then once it was brought into service, it was good to see the guys using it, getting around it and liking what we brought in. It was a pretty good feeling to see it in use, know that the hard work you put in has paid off, and hopefully we're enabling people to work with hazardous chemicals in a safer manner, which is the whole idea behind bringing it in. So the recognition we received CN's Gold Commendation at a clear deck in front of the Fleet Air Arm for the efforts we put in bringing in the breathing apparatus system.
So that was a great example of what our junior sailors can see. They see problems and we fix them. They find ways to do it in innovative fashions. This is also a good opportunity to actually talk about the Innovation Centre, which is actually in Fleet Base East. So for people who aren't aware, we have a centre there which actually has 3D modelling. It has the ability for people to look at problems and actually find ways to actually solve them. They talked about the Shark Tank, so the Fleet Air Shark Tank. There's actually a fleet one as well. So if you see problems when you're going around work and you think that you've got some innovative solution, there's also a forum in which you can actually enter that competition as well. Moving forward for the next presentation, we've got unfortunately Captain Ryan was unable to make it in person. However, she's been able to supply a 2020 snapshot through a 16-minute video. Through Commander Drew and the team at TANG, they put together the video which details the delivery of engineering capability to Navy. It also details how TANG has continued to deliver critical training services to our sailors and officers through this difficult year. Hope you enjoy this.
Welcome to the snapshot of Training Authority Engineering's 2020. I'm Commander Jackie Dew, and on behalf of Director Training Authority Engineering Captain Cassandra Ryan, we would like to show you some elements of TANG's delivery of engineering capability to Navy. During this complicated year, we have delivered our courses against the odds to meet our mission to deliver content to mariners.
The Personnel and Support Department is made up of the divisional and regulating teams. 2020 has been an extremely busy period in which the physical and mental well-being of our sailors have been our highest priority during the statewide lockdown in Victoria. As a fundamental input to capability, it is imperative to continue training the next generation of RAN technical sailors. To this end, TANG Personnel and Support Department has worked to graduate and post out over 360 sailors in 2020. Furthermore, the regulating team took the lead on mounting and providing staff and trainees to support the Victorian COVID-19 Task Force. This included mounting 500 sailors for short notice deployments, from which 130 personnel were committed to the task force. The lockdown in Victoria introduced a risk to the mental health of our trainees, which the divisional teams have worked tirelessly to mitigate by their unwavering support of each individual trainee. Training of our next generation Navy technical sailor does not stop, and we currently have 760 technical sailors undergoing their technical training. It is imperative that whilst in TANG, trainees develop both as sailors and competent technicians. To achieve this, it is recommended that we increase the ratio of student to divisional mentors. As illustrated, Recruit School approximately provides a 1 to 25 instructor to student ratio, and this is reduced onboard HMAS ships to 1 leading seaman to approximately 6 able seamen. However, in TANG, this ratio is 1 divisional mentor of leading seaman or able seaman rank to 95 technical trainees. It is recommended that this ratio be reduced to reflect that of Recruit School, made up of all rates to ensure the development of a well-rounded sailor as well as a competent technician.
I'm Lieutenant Commander James Chamberlain, the OIC of MT School, and my highly dedicated team have enabled us to collectively achieve some significant outcomes for 2020. Throughout the year, MT School has consistently delivered initial entry training to high numbers of MT trainees and closed out the year with upwards of 400 MT trainees in the school, which are distributed between HMAS Cerberus and the Chisholm, TAFE, Dandenong and Frankston campuses. Whilst COVID travel restrictions delayed the post out of some of our newly graduated MTs at the height of the pandemic, we took the opportunity to create simulated workplace experiences with the intention to achieve multiple competency claims within the Cert 3 competency task journals. In turn, this would assist these MTs to be signed off as Cert 3 tradespeople more quickly. Our focus was to target the competencies that proved to be the hardest to achieve for our current fleet MTs. These included top end and bottom end overhaul for the propulsion sailors and PLCs for the electrical sailors. This was achieved by utilising the current diesel engine assets within TANG and manufacturing a purpose-built PLC trainer. 2020 has also seen MT staff and trainees develop and implement a mounting arrangement for the GT training aid that was provided by GE. This unit was mounted with an air gap between the gas generator and the power turbine in order to display internal components of the engine that are not normally accessible in an operational unit. This training unit is currently used within Marine Systems Foundation, however has the potential to be utilised for higher level maintenance courses. The HMAS Cerberus redevelopment has seen the commencement of the replacement fuel laboratory and classroom within the Marine Engineering Demonstration Building, which is due for completion in March 2021. Planning is well underway for the future MT training building, with construction to commence in early 2021. This building will be focused as the Marine Systems Foundation Delivery Centre and will include standard classrooms, Consberg simulator classrooms, office spaces and an open practical training area. The achievements and successes within MT School will continue into 2021, with the forecast being to only increase the training tempo of our most junior technical sailors.
This year has seen a variety of challenges and achievements for ET and CE Tech training at HMAS Cerberus. Our future ET workforce has played a pivotal role in the contributions to the Victoria COVID-19 Task Force, assisting Victoria Police at various locations and checkpoints around the Greater Victoria. Our ET and CE Tech trainees have done an outstanding job adjusting to the state and base-wide restrictions, and have continued to progress their electronics training and graduate on time to meet a variety of new Navy capabilities, including opportunities for overseas courses for both DDG and LHD platforms. Under the HMAS Cerberus Base Redevelopment Project, ET training will receive a new NIDA and IET fundamentals building, which is halfway through its production time frame with acceptance to occur in 2022. We are very excited to promote our new sonar and radar training systems. These systems are set to change the way in which we teach Navy systems and concepts to our sailors in the near future. The Acoustic Systems Trainer is a real-time benchtop sonar system designed for the study of underwater acoustics. Through integrated sound analysis software, we can practically demonstrate sonar principles such as active and passive sonar, volume scattering, acoustic jamming, cavitation, and much more. The radar training system is a computer-based, real-time radar system that operates safely within the classroom environment. Operating within the X-band within 8 to 10 GHz, the radar systems trainer provides an off-the-shelf supported training system that can be utilised for a range of users. Training delivery goals include fundamental radar theory and concepts, to complex and intermediate fault finding on transmitter and receiver operations through inbuilt fault-inducing switches.
During 2020, engineering training at HMAS Cerberus has seen several changes take place, some being temporary to deal with the obstacles that COVID has presented, and others of a more permanent nature. Firstly, our organisation will now be known as the Engineer Officer School, rather than the old Engineer Officer Training Faculty. We have moved to Building 79 at HMAS Cerberus, now that the asbestos removal and painting is complete. Staff changes will see the external course facilitator and senior instructor position brought back to HMAS Cerberus, providing local CQWE level instructing and mentoring capability to the school. Our course implementation officer position and the new operations manager role have now both been filled, completing the new EOS structure. Changes to the engineer officer application course has seen some examinations mapped to assignments to both improve student understanding and foster teamwork. An Assistant Officer of the Day task book has been introduced to help reduce the time to HWC achievement. An oral evaluation board has also been added to help students connect theory to the practical applications and provide valuable board experience for the future. Finally, starting with the current course that has just graduated, students will now be sent to sea with individual training plans to set them up for success. The content of the old STM course has been realigned and updated to meet the requirements of the new TCQ course. The course consists of a 12-week Adele BBB distance learning phase, followed by a 4-week residential phase at HMAS Cerberus. The EOS website is presently under construction, so please contact EOS staff directly for information on any of the EOS delivered courses.
NTSCR currently delivers over 140 individual courses ranging from as little as 2 hours and up to 6 months in duration. In the last 18 months, we will have trained just under 2,000 students. A highlight through 2020 has been the successful repatriation of the CWIS 1 Bravo 2 course from the United States Navy. NTSCR is on track to have trained 5 CWIS 1 Bravo 2 maintainers this year on the inaugural course, as well as bringing an additional 12 FFG and DDG sailors up to the new baseline.
One of the success stories for training support and governance in 2020 has been the DDG Marine Systems Technician course. Built within Adele, it uses a 3D camera to provide students with an immersive and interactive walkthrough of the Hobart class DDG.
TAEng TSG is a dynamic organisation which provides training support, compliance and governance to engineering courses nationwide. TAEng is also responsible for the management of complex training services provided through projects and training support contracts. TAEng TSG consists of 4 key organisations covering initial employment and career training, governance, projects, TSG platforms and systems. In reflection on 2020 and our achievements, TAEng has asked 3 key questions. The first, how have we improved capability, not just training? TAEng TSG has provided significant training support, guidance and advice to new and upgraded capability projects, such as AOR, OPV, Enhanced Cape Class Patrol Boat, IFF, and the Anzac Midlife Capability Upgrade. Effective engagement with key stakeholders, such as CASG, Training Force Projects, NFWB, Capability Managers, SPOs, contractors and SMEs, were critical in achieving project milestones. Subsequently, we were able to apply exceptional foresight and judgment to each project, anticipating the likely risks and develop contingencies to mitigate these risks prior to Navy acceptance. TAEng TSG continues to manage training services contracts for TTSS, LHD, DDG, and recently finished the AOR sustainment contract in preparation for the tender evaluation process. In order to provide greater strategic oversight to training, TAEng sought priorities from the capability managers. This provided TSG with clear objectives in order to mature training to support each capability against the operating and supporting intent. The second question, how have we improved TAEng? Through the implementation of a change proposal process standard instruction. The TAEng Change Proposal SI was refined through stakeholder workshops, taking into consideration requirements of training support contracts. The release of the SI was communicated through the Training Force induction process, which was well received. Throughout the year, TAEng has seen an enhancement in our continuous improvement process and the overall status of our curriculum health check. Staff now have a greater appreciation of compliance and the role of TSG-Eng in this process. Another significant improvement to TAEng has come through the Governance and Assurance Cell, who have worked hard to revamp the procedural framework governing training at TAEng, implementing a new TPR form that enables a more efficient and effective way of capturing training progress records. This form has been so well received, it has been adopted by other training authorities. Another noteworthy improvement to TAEng has come in cross-platform training. Various gap analysis tasks were conducted across TAEng to determine which courses had the potential to be delivered as a generic cross-platform course. The capabilities included NIXI, IRST, and gas turbine. Cross-platform training allows for efficiencies, including the implementation of a common PPP across identified platforms, resulting in greater posting flexibility and a reduction in training. And finally, how have we made our customer happy? TSG strive to adapt to new, changing or challenging situations within the training environment, which we've certainly seen in 2020. Innovation is one means of achieving this. For example, TSG have recently developed a DDG Marine Systems Technician preparation course, which aims to reduce the duration for trainees to receive platform endorsement. In the absence of a Hobart-class DDG platform, an immersive DDG Marine Systems Technician 3D walkthrough resource is currently under development. And finally, within TAEng TSG career, at HMAS service, over 400 sailors have been awarded nationally recognised qualifications, thanks to the important work the TSG career team have done behind the scenes, validating, updating and aligning training to the requirements of both Navy capability and the Australian Skills Quality Authority.
Have places all over. And what's more important is actually seeing what they've actually done. With the advancement of technology, we need to also make our training contemporary as well. Moving on to the next one, I guess once we've trained people, we then need to figure out what we're going to do with them, where we're going to post them. And so that brings us to our next presentation, which is NPCMA, and we'll be joined by Lieutenant Commander Kai Wakefield. So as you can see, we've got a little bit of technical difficulty, so just bear with us. I guess when we talk about TANG, some of the big things which have happened there has been the improvement of the NESCs. So the different NESCs, especially in Sydney, what we have there is a whole new facility at Randwick Barracks. There we have simulators for LHDs and DDGs. Also what we have is NESC over at HMAS Watson, which has simulators for DDGs as well. Did anyone have any questions in terms of TANG? No? And I guess another thing to take note is that with Cerberus and with the facilities there, they're actually at capacity at the moment. We have hundreds of junior sailors in the training pipeline as we speak. And for some of the training, a lot of them will be looking at the new platforms, especially the DDGs. And where they go after that is actually to the States. So when we talk about outplacements or other ways to get overseas or different jobs, DDGs may be an option for you. Okay, without further ado, I'll pass you on to MPCMA.
MTs on board. So we're looking to the MEOs out there to push their commands to utilise any extra bunks on board for MTs. And finally, as most of you will be aware, the promotion requirements for ABs to
Sir, ma'am, ladies and gentlemen, my name is Lieutenant Commander John Robarts and I am the Navy Crew Zero MEO and I've been...
postpone NPCMA until we sort those technical difficulties out. Moving forward though, we have a really interesting video noting that Navy is embarking on a huge journey in terms of building more ships and more capability. What we've got now is a video on the Navy construction branch. Thank you.
Sir, ma'am, ladies and gentlemen, my name is Lieutenant Commander John Robarts and I am the Navy Crew Zero MEO and I've been seconded to the Naval Construction Branch. I'd like to provide a warm welcome to Chief of Navy and the other senior leaders who have attended here today, and thanks to Captain Carroll for allowing me to virtually present in this year's Fleet Engineering Forum. So to provide some context, I was requested to write a service paper for the Naval Engineers Advisory Group on the contribution of engineer officers to the naval construction enterprise so that the naval engineer career continuum can be updated to reflect the extra roles that our Navy will need to provide. I've used some artistic license today to ensure that we're keeping the context of the service paper relevant to the Fleet Engineering Forum for 2020. So rather than just talking about how engineering officers contribute to the naval construction enterprise, I've related it to how all technical members contribute to the naval construction enterprise. Now, if you're a naval architect like me, or you have an unquenchable thirst to learn how and why ships operate the way they do, it is a very exciting time to be in the Navy, even with COVID-19 persisting. In 2017, the Australian government announced the Naval Shipbuilding Plan, which outlined the vision for the naval shipbuilding enterprise to be located in South Australia and Western Australia. The Naval Shipbuilding Plan was delivered at the twilight of the Air Warfare Destroyer program, part of which was to reinvigorate Australia's shipbuilding capability to address the generational skill gap and ageing infrastructure. The plan defined the construction of 12 Arafura-class offshore patrol vessels to replace the Armidale-class patrol boats, 9 Hunter-class frigates to replace the Anzac-class frigates, and 12 Attack-class submarines to replace the Collins-class submarine. Now, I don't know for certain. However, I believe that we're probably going to be constructing other projects throughout the naval construction enterprise as other acquisition projects come to maturity. So the RAN's response to the Naval Shipbuilding Plan was the creation of Navy Crew Zero. So Navy Crew Zero was implemented by the Navy Capability Committee as they concluded that the current measures to support shipbuilding and delivery activities was unsustainable and unsuitable for continuous construction and continuous acceptance into the RAN. So one of the key outputs is to provide improved support to the commissioning crews, allowing the commissioning crews to focus on whole of ship and force generation type activities and allow the construction activities to occur in a separate location with the ship eventually delivered to the vessel's home port to the commissioning crew. So the key roles of Navy Crew Zero are to inject Navy subject matter expertise into the shipyard, support test and activation activities, as well as to create an environment for the rapid development of knowledge of the ships. So the idea is we know the ships before they even hit the water. CASG's response to the Naval Shipbuilding Plan was the creation of the Naval Construction Branch. The Naval Construction Branch is intended to be the storehouse of shipbuilding expertise within Australia, provide management and oversight of shipbuilding infrastructure, as well as be the on-site oversight of naval construction activities that happen in Osborne Naval Shipyard and CIVMEC. So you might be asking yourself, how can I be a part of the naval construction enterprise? So you can get posted into the Naval Construction Branch's organic billets through NPCMA. You can be posted through TAEng, which I'll go into more detail later on, or you can be posted into Navy Crew Zero. So Navy Crew Zero formed a series of memorandums of understanding with the Naval Construction Branch so the technical members can be injected into the shipyard to support industry and also to meet the intent of Crew Zero, particularly gaining rapid knowledge of the design and understanding how the vessels work. So when someone like myself posts into the Naval Construction Branch or is seconded to the Naval Construction Branch, they are inducted into the shipyard, allowing them access and free roam. The construction branch retains a few key members to be able to support those on-site oversight construction activities, and the remainder of the members, in particular junior sailors, are injected into the shipyard and are augmented by industry. So what does this mean for fleet? When a vessel enters into service, we'll have technicians and engineers who have been working to build the ship and set the ship to work and will provide a deep level of system knowledge unlike any other delivery program we've recently experienced. It also offers a potential retention strategy, allowing our technicians and engineers to work in a heavy engineering environment and to grow their technical skills and capabilities while working with industry. It also eases the performance of the vessel when transition into service occurs. So rather than just the commissioning crew having the requisite training and knowledge of how the platform works, you'll also be able to have an extra industry base as well as an extra base of Navy members to be able to provide these support activities right here in Australia. So what you see here is the Navy Crew Zero cycle that will interact with the construction branch and the shipyard itself. So the first point is when you have someone like myself who's joined approximately 12 months ago, we integrate with the construction branch and with the shipyard, and we start drafting the first iteration of orders, instructions, and publications. Whilst doing this, we're also gaining an intrinsic level of knowledge associated with the vessel's design. So we start to understand how it works, and we're translating how it works into what we see in the shipyard in construction activities. So the shipyard will see the ship for what it is, undergoing construction and understanding the productionization of a design. From the Navy perspective, we see the ship for what it will be once it enters into service and understand how it's going to operate and be able to identify any issues and risks. So the second phase is the industry support phase. This is where new joiners to the construction branch, whether they be posted or seconded, are injected into the shipyard and working with the industry suppliers. So already, for example, using the OPV as a case study, we've got junior sailor, leading seaman electricians who are integrating with the subcontractors, and they are installing cabling throughout the ship. So as the vessel gets more and more complete and it starts to enter into the acceptance phase, we now have a base of industry and a base of Navy who understand how the ship's been put together. And this is where I think Navy really truly comes to its form, as we now have the understanding of how the ship works, we understand how we operate the ships as a Navy, and it allows us to support acceptance trials and builder C trials. So during these acceptance trials, it's also our first opportunity to validate the OIP that we've drafted in the earlier phases, as well as getting an understanding and a feel for how the ship operates when it goes to sea for the first time. After SATs is the delivery phase. So it's around this time that we expect to lose a number of Crew Zero and Naval Construction Branch personnel, and our vision is that at least 30% of the technical department for the vessel being delivered is sourced either from Crew Zero or from the Naval Construction Branch. So this should allow an appropriate balance for the vessel to have a level of inherent organic knowledge and technical capability on board, but also so that we can continue to meet our priorities for the next vessels that are under construction. So we're now entering the phase where the vessel is entering service. You have a technical department that has been sourced from other areas of Navy as well as the Naval Construction Enterprise to provide an appropriate level of technical capability on board. But it's important to also remember that with the existing technical workforce and engineers that are working ashore can also provide other support activities to the vessel's delivery, particularly for first of class. Some great examples that we envisage of being used to is by support to sea training group to ensure that they understand the vessel before they step on board to be able to test the capabilities of the vessel. Support to operational test and evaluation, providing advice to risk assessments and provide that understanding of how the vessel will operate and how it's supposed to be operated. And it's important to note that the vessel needs to be tempered between how the Navy operates the vessel and to ensure that we're operating the vessel as designed to maximise capability. Now, once that vessel is delivered, it's into service and the training wheels are off for the commissioning crew. This is when we start to focus on delivering the next vessel. So as a great example, the OPV cadence is expected to be approximately 9 months between delivery of each vessel. So what that means is at least 30% of the technical departments on board those ships will be sourced from the construction branch and Crew Zero. And then in the meantime, they'll be busily supporting the delivery of the next vessel, ready for the next tranche of sailors to join as a commissioning crew to ensure that each vessel has an appropriate level of support as the vessel enters into service. So to give you some case studies of what we're experiencing at the moment on the OPVs, we have electrical sailors who have been seconded to Marine Technicians Australia, who is the prime subcontractor for the electrical fit-out for the vessel. MTA benefits from the provision of skilled, disciplined, trained labour provided by the Navy, and the Navy benefits because rather than understanding how a vessel works by studying a diagram or reading one of the technical publications, they are installing the cables throughout the ship. So just the other day, I quizzed one of our sailors who are working in the yard around, do you think that there's a level of skills and knowledge that have been sourced here that is not available anywhere else? And without hesitation, his answer was absolutely. And the reason for that, and he goes this great little case study where he said, I understand where the cables go throughout the ship. So I understand how they start and where they finish. And what I didn't realize was that for every compartment within the vessel, there is one spare cable of the same size that feeds to and from that compartment. My question was, do you understand what that means? Like, could you find that in a drawing? And his answer was yes, but you wouldn't know where to look unless you found it. We now have that knowledge. We now have that capability, and that will provide direct support to the vessels once they enter into service. Another great example, TA-Eng. Our trainee fabricators are leaving HMAS Cerberus. They are posting into the Naval Construction Branch and being inducted into the yard, with ASC welding the ship together. Now, it's important to note that in order to be a welder within the shipyard, you need to have class certified weld procedures and class certified welders. So what that means is every welder that comes out of the shipyard is class certified. Once they have completed their journals and they are now certified as a Cert 3 fabricator, they are then posted into FSUs, in particular FSU Southeast and FSU West, to provide more support to the fleet. So for the context for our WE officers and our ETs, we have a growing presence as the level of construction becomes proportional and leans more towards comms, sensors, and combat systems suite on board the vessel. So at the moment, it's embryonic, but we expect it to grow. We have one ET who is currently seconded to SARB, who is supporting and providing maintenance and advice to how the OPV's communications and sensory suite will operate on board the vessel. And for the engineer officers, and particularly for the senior sailors, we're providing direct support to the production management and propulsion install onto the vessel. So as a great example, we're providing production support to the shaft install of the OPVs. So this is where we get a good understanding of the factory acceptance tests that have occurred on the vessel. We understand how that's contextualized in the shipyard, and we understand the process to install the shafting. That provides us a deeper level of capability than we have not historically experienced until a vessel enters a deep cycle of maintenance. So for myself, I've not been seconded out into the shipyard. However, I'm working with both the shipbuilder and the ship designer to ensure that the design conforms with the standards that we have and to get a good understanding of how the design needs to be certified for when it introduces into service. And this is to provide some great advice and feedback to ensure that we're collecting the right data and we have the right information pre-positioned for the support organisations as they gain maturity in the coming years. So now we move on to the more soft skills by having a deeper level of Navy involvement with industry. So I've experienced it myself over the last 12 months, and I know that it will continue to grow in the coming years, there is a steady but slow cultural alignment between how the designer and the shipbuilder understand the vessel, as well as our perspective on how the vessel should be operated. So slowly but surely, we learn the language of the designer and the designer learns the language of Navy, and we start to form an aligned view on the proportionate level of activities and the proportionate level of support that we will need when the vessel enters into service. So another way to look at this is from the shipbuilder and the ship designer's perspective is that they're working with the customer in the room, which I think we can all agree will have an inevitable impact on the shipbuilding quality of the vessel. And I think that's evident when you're looking at and you're observing our sailors working alongside other members of industry and we're all building the same ship. I feel like they will have a cultural impact on how the shipyard operates, and particularly for ourselves as the navies, that we'll have a higher level of confidence that the vessel is going to meet our expectations and we'll be able to deliver the capability. It's safe to say that because we're now continuously constructing warships, that we are now forming strategic partnerships with those suppliers rather than a singular transaction which is destined to finish. We're expecting to see design refreshes and continuous manufacture happening in both Western Australia and South Australia moving forwards. Not to mention that we expect to have the ongoing support from the designers and probably the shipyards as well to support sustainment and major upgrade activities as we move into the world of warship manufacture. And lastly, but certainly not least, I think one of the most important things that Navy provides, particularly while we're out in the yard, is that we form and become the ambassadors for the thousands of sailors who will call this ship home in the following decades. So to wrap up, I'd really like to highlight that this is just covering off on a few aspects of the service paper and that there's further examples of how The shipyard and the designers' activities that we're doing in Osborne and Henderson can also provide further support to the sustainment organisations and therefore supporting our maritime capability. So thank you very much for your time, and I wish you all a safe and relaxing reduced service period. Happy New Year and a Merry Christmas. Thanks very much. So as you can see, down in Adelaide, it's not Sleepy Hollow there. There's a lot of things happening there. With all the new capability coming online, we need to have plans. And as you can see, there are definitely plans in place. Our next paper is something which young engineering officers can actually align to. One of the big things about coming out of training is actually doing your time at sea as an AWEO or an AMEO. And then once you pass your CC, your next bit is then posting ashore. So the question there is, what are the expectations for CC engineers when they go ashore? So I've got Lieutenant Phillips here, who'll take us through that.
In your offices? Yeah.
Ma'am, sirs, thanks so much for giving me the opportunity to speak in this forum. Like the previous presentation, I was asked during the recent MEAG-WEAG meetings to present some points. That turned into a service paper, which led to me being able to present this to you right now. It's a topic I'm quite passionate about. For those junior sailors and potentially more senior officers, this is going to be extremely junior officer focused. But it's good. So the question that got me thinking when it came to this presentation was an ME/WE trained force employment. We're predominantly shore-based. Of a whole career, you might do 4 years at sea as a trained engineer. But all of our training appears to be sea-focused, which leads me to the question of what can we expect of an engineer in our shore positions? So behind every ship, there is a dedicated team. And part of that team is we have our engineers. So who are the engineers? We're driven individuals with our prerequisite engineering qualifications, achieved through undergoing significant training continuum and gaining relevant experience and skills that in theory allow us to move easily between positions. Or does it? Our shore-based employment compared to our sea-based training has the potential to leave some gaps, which in the long run will reduce our effectiveness as an engineering cohort. So the aim of this presentation is to give you a background, to establish a bit of a starting point of where we got to. We're then going to look at a question set to drive the discussion amongst us, the engineers, and the broader community. And then I'll present just one person's view for a way forward to reach a solution. So as this paper was submitted for MEAG-WEAG, I've restricted this to only consider the ME and WE streams. So who are we? Engineers can enter the Navy through a variety of methods. They're going to have very different educational foundations. There's multiple ways to enter the service, and you're going to spend your time on any number of platforms for award of your CC. That CC being a logical test to set a required baseline for a level of employability. You achieve that. You then move into your shore posting. Sometimes they have slightly confusing job titles. Sometimes they don't even have a position description. So you end up with a desk with a CC engineer, sits down, logs on to the computer system and goes, oh, what on earth do I do now? There are multiple entry paths. Got the engineering officer screen. You can join as an undergraduate. You can go to ADFA, be a graduate engineer, be an associate engineer that comes up and through. There are multiple different degree streams for ME and WE. And then when you combine that with a number of platforms, you essentially get 150 different possible combinations for an ME officer and 140 for a WE. So we're starting at this broad point. We all then funnel down to our CC. AMP 2110 tells us the successful attainment of a Navy engineer CC also signifies the minimum level of competence required to fill a deputy engineer officer position in the surface combatants and aircraft squadrons and for commencement of charge program in the submarine squadron. That statement, I think, succinctly articulates the required end state of the CC training continuum. But when we read that in conjunction, and when you read that in conjunction with the expectations of your deputy engineer, it's quite easy to line up, this is what we have, work back, this is the training that we need to meet that position. 2110 then goes on to say, while aimed specifically at preparation for deputy roles, the CC also provides the basic level of engineering knowledge required to complete a substantive shore posting. And that's all it says. There's no further qualification to this. There's no expectations outlined, and it gives no further detail about what training is required for these individuals. So when it comes to what we have now, the expectations of the CC engineer are essentially their immediate level supervisor, which can be varied depending on where you are, what you're doing, and I think quite heavily on the relationship between the two individuals. As we look at our Plan Polaris for 2022, workforce is our highest priority. Outcome 4 is that we need to effectively lead and manage our people and culture. For me, this sets up a natural conflict if we have a potential for underutilisation of our engineering workforce. At the time the service paper was written, there were significant gap billets across the CC posting plot. And when calculated out to a number of hours or productive hours each week not being completed, came to a number that I was not comfortable with. It's therefore critical that the current CC workforce is fully employed so that we're meeting CN's and Navy's intent. As our Navy changes to meet our current and future needs, it's only natural that what we ask of our engineers is going to change with it. What worked and was suitable in the past may not fit a rapidly modernising and expanding organisation. So by evaluating our current situation with an understanding of the practices of the past, but looking forward, the end state for our workforce is that we need to come up with a justifiable and defendable set of expectations for the CC engineers. The bad news is this is not exactly a simple task. The diversity in the room, the diversity in employment and geographical separation means that we need to ensure we conduct a deliberate requirements analysis to ensure that all aspects of this are systematically addressed. And we need to do this with a cross-section of the engineering community. We need to develop that sense of ownership that what we expect of ourselves has come from us, so that we know what we're working towards. So to aid in this development of the expectations, I'm going to recommend a series of guiding questions, which when used in more of a working group focus, will be used to guide the discussion. The first one is, in what functional areas are CC engineers employed? Look at the big picture, separate it down in that first level of chunks. Group those like functions so that we can establish efficiencies. We then need to consider what level of autonomy can you expect a CC engineer. When thinking about this one, I'm going to recommend trying to separate from our established risk management levels and previous engineering authorities, and think we've just spent all this time, this person's got 4 years of university training, and we've given them an extra 2 years of on-the-job and theoretical training. Let's make them do some work. What's that going to be? And as engineers, we're also officers. So how many people can they manage? If we put them in a purely people-focused role, what's the most they can do there? Now we have what they can do with the people space, what they can do in a purely engineering space. What's the balance that we want our engineering officers to be doing in these jobs? And once we've set that foundation, only then can we ask ourselves, for each of those functional areas, what tasks can be reasonably expected to be completed by an engineer with a CC. So my proposed way forward. I think these are going to be extremely useful. We're going to be able to use them to guide day-to-day work. NPCMA will be able to use these to affect their workforce planning. So this will be my roadmap for the implementation and the use of this expectation set. First, I think we should review the CC engineering plot. We need to identify where we're putting too much resources and too little, and then look to do a redistribution of the CC cohort to meet the actual need across Navy. Where we identify that we've got shortfalls, we train. We have some fantastic training staff and experience that we can leverage off. We want to use that to bring up the level of engineering to meet that baseline. This training will then get re-rolled, so that as a CC engineer posting off a ship or crossing across functional areas, you've now got a training package. This now reduces your lag time, and instead of sitting in that chair saying, what on earth do I do now? You can be productive from day one. You can make a significant contribution from your first day without getting that deer in the headlights look. Communication of these changes will be critical. As anyone who's lived the dream of significant change management through an organisation will be able to tell you. Therefore, I'm going to recommend we use an existing program to build upon, so we're moving from an unknown and then progressively introducing the new. For this, the Navy Engineering Career Continuum already broadly categorises jobs across the following areas: policy and assurance, operations, systems, covering sustainment and acquisition, and construction for shipbuilding. Each area would have its own training package and allow that smooth transition from the assistant engineer through to the first shore position and even your second and third one. So my recommendations, in summary, that we hold a series of workshops across various locations in Australia where we draw on a cross-section of the engineering community to work through the question set I alluded to earlier. We then aggregate and review these responses at the next suitable MEAG-WEAG meeting and prepare the submission. If approved, we broadly integrate these expectations into all current and future policy and procedures relating to the employment of CC engineers in shore position, and that we review these engineers in no more than 10 years from the date of their approval to ensure that we're remaining relevant to the current Navy need. I think CC engineers can make a significant contribution to the Navy engineering workforce. Engineers have an incredible variety of experiences that they can bring to a shore role, but they need to be harnessed in such a way that they're going to perform optimally. Confusion and uncertainty of what is expected from a shore engineer can be sourced from many areas. What is clear though is the need that a defined set of expectations of what the engineers do. Through a consultative approach, arriving at a justified and defendable set of expectations can be developed, and it's going to be backed by a rock-solid rationale. Once complete, Navy as an organisation will be in a position to know where its shortfalls exist and take deliberate action to remediate them. This will allow Navy engineering to change and adapt to a rapidly modernising environment. Thank you. Now, this is a group of exceptionally experienced people. I would really encourage you to ask some questions if there's anything in there in relation to the question set, or perhaps you've got some answers already. Em, do you mind grabbing my prizes for me? In order to encourage questions, I work at DFR, so you never come to these things empty-handed. You have the opportunity to win some bits. People in the outstations, your reward is knowing that you've contributed to the discussion. Well done. Lawson, is there any way that people can, from outstations, can get...
Signal, and I'm keeping an eye on the YouTube comments.
Thank you.
I got one for you because I'm always going to ask a question. You said you brought it up in the MEAG and WEAG, right? And everything you said makes sense, and you said you made a recommendation. What actually happened at the MEAG and WEAG? Why is it not? Can we wait for it to go further, or you got to put it up again?
So the first one was just a brief summary of the outline. President of the MEAG, WEAG then volunteered us to create a service paper, the presentation of which was delayed due to sort of a bit of a full schedule, and the recommendation was to present it here. So I'm going to take this, I'm going to take some feedback, I'm going to do some more work, and then if I can get the concept approved, I'd love to crack on. It's a good question. It's all yours. Be careful.
Thanks. Sam Phillips, I was at Forster here, another fellow NECC. More of a, I guess, discussion point. What I found really useful, which I think all engineers can kind of gain from, is having on average we're having about 2 to 3 short postings before we go back to see as deputy. I think it's really important to have kind of a technical short posting along with a personnel management posting to diversify. A lot of people are getting 1 or 2 technical postings back to back without having any experience of personnel management. Whereas I've kind of had the technical experience followed by personnel management, which I found real beneficial, and I think it sets you up better as a deputy when you go back to see.
100% agree. I've only recently jumped into a more personnel management focused one, and I'm learning every single day about things I didn't even think I didn't know. Zinger or a pen? Good work. Sir?
So Lieutenant Phillips, with your next posting after being at sea, would you prefer a personnel focused job or a more technical one to grow professionally?
That's a really good question. I think for me, personally, I needed the technical one. I needed to get my head, just my sort of rather unique journey throughout this career. It means that I need to get my head out of more operations focused and get into the technical posting. And I was fortunate to be able to work with some really experienced people and grow my technical knowledge there. But if you're coming out and you're super strong with your technical and your board performance indicates that, but you might have some shortfalls in personnel, let's play that easy win. Get them in the personnel position as a junior engineer and they can learn. And we sort of do that balance and everyone comes up and ready for that deputy time where you really bring in that unique blend of personnel and engineering management. Oh, you've probably got heaps of these. So, fleet wares don't count. Another question, I've got one more pen to give away. Would not want to miss out on this. That looks like it. Thank you for your time, ladies and gentlemen. Sir, ma'am.
Great, thank you very much, Richard. Really appreciate it. You raised some really good questions. As you can imagine, being a junior officer, going along in your engineering continuum, these are the things which they think about. You work really hard to get to your CC, then the next bit is, what do we do next? So, and am I prepared to actually go into my next role? So, great questions there, Richard. Moving on to our next one, what we have is, as you're all aware, CN's intent is about having an Australian thinking, fighting Navy. So when you talk about fighting, There are images of PWOs or MWOs in the ops room, and then there's everyone else. What we need to do is actually change that. The future Navy is going to have technical people within the operations room and the CIC. How that actually works is through a collaborative sort of arrangement and relationship. So the next speaker is going to talk about the interdisciplinary collaboration between engineering and warfare communities, because without it, I don't think we're going to be as successful as we can be moving into the future. So this is Lieutenant Kai Johnson. He's currently come back from the United States from doing Aegis training, and he currently works at the Maritime Warfare Centre.
Hello senior officers and the Fleet Engineering Forum. I am Lieutenant Kai Johnson, currently the SO3 Weapons Test Engineer at the Maritime Warfare Centre. Earlier this year, I was asked to give a presentation on cross-pollination of the engineering and warfare communities and its effects on lethality for the WEAG, which has progressed into the paper I'm presenting today. Before I give you a quick overview of what the paper is about and address some recurring questions, I think it is necessary to provide some context. First, my paper focuses heavily on what the engineering community can do to better facilitate interdisciplinary collaboration. This is not meant to diminish the importance of the warfare community's contributions or actions to achieving the same goal. Second, this paper has been created from collaborations and discussions with over 40 engineering and warfare community members. However, has been shaped by my experiences at Fleet Engineering, the Maritime Warfare Centre, and a large amount of interactions occurring between those of and slightly higher than my current rank. And finally, some of you who have read my paper may feel that it does not follow a typical service paper theme and that it is more heavily academic. This was deliberate, as while I make a recommendation on how to action or facilitate change, I wanted to demonstrate that the concepts in my paper were based on objective evidence as much as possible. So, let me start with the problem. As technology advances to challenge an ever-changing range of threats extending beyond the maritime warfare domain, the traditional delineation between operational engineering and warfare is no longer sufficient to provide lethality to the capability manager. Although the broader problem is quite complex, the areas I address in this paper can be summarized in my belief, backed by academic evidence, that in order to get the most out of our current, and more importantly, future systems, the engineering and warfare communities must integrate to allow faster, more coherent transfer of information, and each community must equip itself better to engage, collaborate, and action items in each other's domains. Without this, we, not just as a force, but in terms of our cross-force interactions, may not achieve the most efficient or effective outcomes, providing vulnerabilities or failing to maximize lethality. My paper goes on to discuss interdisciplinary collaboration compared to multidisciplinary approaches, the barriers found in the RAN against it, and recommendations for the engineering community to address them. Rather than go into these issues today, as they are discussed in my paper, I would like to address 3 statements that were raised multiple times during the research of this paper. Any points about the paper or related topics? For those who haven't, I've socialized the idea of better on warfare community, or even our own, and if this serves as the catalyst for it, then it has done its job. Thank you.
Okay, I need to put my glasses on because I'm blind. Okay, good morning everybody. My name's Captain Naval. As Fleetwear said, I'm the Executive Director, Fleet Support Unit. I joined FSU, taking over from Greg Laxton in July, so I've only been here a short time. Just to update some of the figures, we now have 969 personnel on the books, and that's from Impact, and that's growing monthly because really what's happening now is we're taking in all the new trainees that are coming out qualified from Cerberus for their Profile 21s. We are taking up to 45 a month at the moment, so we're building and we'll continue to build. As everyone here, we've been it's been a really challenging year, but as Warrant Officer McLean said earlier, there's been a lot of opportunities that COVID has presented us. Certainly at the height of the COVID, we had 12% of our personnel actually assigned to COVID task force around the country. However, we still maintained full delivery of full capability. And to be honest, in the April-May period, our utilisation actually increased to the highest it's ever been in the history of FSU. So that's real testament to our people. We also introduced a number of different methods of working. We had split shifts with our teams in Cuttable, where we were working essentially 6 days a week, one team working for the first 4, one team for the next. And we're continuing with a number of these work streams because actually the productivity increased and our staff actually enjoy the way we're working because it suited their, gave them a bit of a family work balance as well. So we're really looking at the way we work as well, but while still supporting the fleet. Okay, next. So really, the role of FSU is twofold. Delivering excellent sustainment outcomes and providing meaningful work for our sailors. I'll be upfront, my focus is on the second, the providing meaningful work for our sailors. Because if we can fulfil that, then providing sustainment outcomes will look after itself. I currently employ about 6% of the Navy's workforce. We've got engineers, technicians, and also bosuns. A lot of people don't realise that we've got a significant number of bosuns mates attached to all our FSU regions, delivering surface finishing applications in all regions. So it's a big, wide and varied workforce. Okay, next. These are our objectives for 2021. Our objective for this year was to meet a sustainment target of 45 million in sustainment offsets, and I'll go into that in a minute. So next year we've given ourselves a stretch target of trying to deliver $60 million in sustainment offset across all classes, productivity with a target of 80% utilisation. Some people ask me, why isn't it 100%? What we look at is we actually look at what our people do, and we have to take into account leave, MAT training, courses, sport, all these things that you do and take for granted. Because we're measuring everything we do in FSU, everything gets measured, and that's why we're looking at the 80% offset. We're never going to achieve 100% because our people wouldn't get any leave, wouldn't do their MAT, wouldn't do their sport, etc. Okay, so that's where the 80% comes from. Our second objective is to align FSU processes and impact development with Plan Galileo and ERP. This is key. We're all moving rapidly towards regional maintenance centres. The first ones are standing up in Cairns and WA in the not too distant future. I have members of my team and myself on various working groups, along with Captain Hurst with Plan Galileo and the RMCs, how we're going to work and embed ourselves within those centres. Next one is measure consistently high quality of maintenance and regular repairs be regarded as the preferred maintenance provider. All of our work is measured in impact, and everything we do is measured. Position FSU as an industry leader in proactive safe work systems. I've currently a reservist commander working for me, doing a safety project, trying to build the safety culture and make sure we are a proactive safety focus in all our work. That project will likely continue to run for certainly the first 2 quarters of next year, but hoping to have it completed by Q3 21. Establish workforce stability through Navy Workforce Generation System. So obviously with the future workforce model, where we've got CSRGs being stood up currently, Darwin and over in the west with the submarines, we're looking at our position in our workforce in the CRSGs with the obviously the ready and reset model, and that's where I think you mentioned training and having key ring fence positions. We have ring fence positions, and out of the ring fence provide a dollar offset against what we're doing. We're working at the moment to try and get the granularity by getting portal data in the amount of work we've delivered. So we're continuing to increase with the delivery while still having more people joining. So that's a challenge that we need to deal with. We're becoming a little bottom heavy with the number of junior sailors we got joining. And that's a challenge moving forward that my team are looking at how we're going to manage that with supervisory and divisional responsibilities. Okay, next. So, production quality. You'll remember what I'd say probably the not so good days of FSU where a lot of work was handed back for various reasons. A lot of those reasons have now been alleviated. We're not seen as a body shop. People aren't pulled out of us at short notice and sent to sea to fill gaps anymore. There's a more defined process in place, so we do have a stability for our people. So the actual take back, or shall I say the hand back of FSU, is decreased massively. This year it's 1.3%. The take back is where CASG takes work back off us. And there's a number of reasons for that. Schedules may change, there may be unavailability of parts, etc., so they have to take the jobs back. And the actual rework, that's where we've done a task, and for whatever reason it hasn't been up to standard, is 0.1% this year. Now I suggest that stands pretty well against industry across the board. So our actual delivered, we've nearly delivered 92% of all work we've taken on, we've actually delivered 92% of that. So the improvement in our delivery has been quite significant over certainly the last 2 years. Okay, next. So these are just a few of the achievements from this year. We actually won the Australian Business Awards for process improvement this year, and that was down to the work of my impact team, Lieutenant Commander Tran, Kelly Naylor in the planning office, to actually improve the processes that we've got in impact and actually deliver the fidelity that we require from our data. We had a really successful deployment of a deployed maintenance team to a runter in Darwin. That was made up of a team from Cairns and also from Stirling. We had 16 personnel, assisted a runter in a number of planned maintenance, defect rectification, and also gave the ship staff a little bit of respite and downtime. So that was well received by the CMR and also the ship staff up there. And we're going to be doing more of this into the future. Whether we're forward deployed or we send maintenance teams, that's going to be one of the key roles I see us as we move into the RMC phase of Plan Galileo. Cairns fabricated LCM8 loading ramps for the Army. That again was using the fabrication skill sets of our people in Cairns. As Warrant Officer McLean mentioned earlier, the NOLCA installation on LHD was really successful. That was really good collaborative effort between Navy, CASG and BAE, and we helped with the install, set to work, and Adelaide went on their way with a fully functioning operational system. Combat system alignments, as was mentioned earlier, the LHDs, ANZACs and also the EDG. One of the big achievements I think over in the West is the integration of submarine workforce into FSU with the stand-up of their CSRGs, their overseas maintenance crew have now moved in their entirety into FSU in Stirling, and we've now got a regional manager who's actually a submariner as well. So I see the work in the submarine space increasing over in WA, which is a really good positive achievement. And this final one down at the bottom there, the mine-shaped training aid, that was designed by one of our midshipmen that was on a little bit of a how long was he here for?
Since March, sir.
Okay, so we've gone for a bit of a while. So he's just seconded to us for a short period of time. He actually helped design, our people manufactured, and it's actually been tested. There's video, I believe, of the test. It's well worth a look. It works. The divers love it. So we're going to manufacture more, and it's been a real success story. And I think, how much did we save on that one?
That was about 15,000 we saved.
Yeah, so we saved Navy a significant amount of money, and we also used the skills of our people to actually manufacture. Okay, next. Okay, so the future, next year and beyond. Building 66, this has been a real achievement. We took over Building 66 from Thales and the FFGs as they finally paid off. Officer Sol and his team have moved in there. I believe we're trying to build repair scenarios where the team can wear the halo visor, and actually it would talk them through repair scenarios. And as we build forward with that, we can see potential whereby we could have a subject matter expert sat here. Someone could be anywhere around the world with the halo on their ship, and we can talk them through a repair on their kit. So there's a lot of, I see a lot of promise in this trial, and that will start in the new year. Artificial intelligence, robotic process. We're using robotic processes. I've got a couple of my guys up in the Pitt Street trained in these processes. So we're automating a lot of the transactional type things that we do day to day, you know, saving files into Objective, etc. So we're actually saving a lot of time on our workforce, and it's actually freeing up at the moment. I think the amount of time we've saved, we've actually freed up 2 personnel that can actually do other things. So we're building on that moving forward. Additive manufacturing, we've teamed up with Trollboat SPO and also Curtin University in Darwin. We've got a 3D printer up there. A lot of our team have been trained how to operate and do additive manufacturing, and we're really stress testing the art of the possible here on this. It's still obviously still policy being reviewed before we can actually launch into full-on manufacturing components for our ships. And we're seeing an increased ET workforce, and there's areas in that work stream potentially where we may be doing secondments into guided weapons, etc., in Orchard Hills and over in Stirling into the future. As we said earlier, combat system alignment work, and obviously Aegis maintenance. Okay, next. Okay, Impact. That's our tool, which is owned by FSU and developed by FSU. I have a team of coders and developers that work full-time using the Impact system. And basically, what it is it's centralized, transparent, and auditable data. And it's linked to external databases such as PM Keys, AMPS, Millis, etc. Gives us real-time analytics, which basically drives our workforce behaviour. Every single task our people undertakes is recorded in Impact, whether it's production, i.e. sustainment activities, or productive. And productive could be things such as COVID task force, etc. But we track and manage everything we're doing within FSU across all regions. Basically, it decreases the admin load for regional plan teams, gives us real-time access to the workforce, and real-time calculation for internal and external entities. A lot of our data, which I'll talk about in a minute, is we're offering up to CASG to enable them to produce some metrics to really report on how we're performing from a utilisation and cost offset perspective. Okay, next. So this is really our roadmap. Three distinct plans. Plan Galileo alignment. Everything we're doing at the moment is we're linked in with the Plan Galileo team and their subcontractors to build the metrics that they want to enable them to utilise us better. And ideally, that would be a consistent data reporting across the 4 RMCs when they finally stand up. Enhancing FSU operations. So that's just upgrades to architecture, digitalising much more of the activities that we already do. And the final one is ERP alignment. More AMPS data integration. Azure protected, that's the cloud. And the Impact C isn't having impact at sea, it's enabling us to get the data from sea. Okay, so there's no confusion in that area. Okay, next slide please. So you can see from that slide, slight changing really in the focus of our strategic progression. Where we said in 2020, utilisation and optimisation, we're now looking at sustainment value realisation. So that's actually, we've got the utilisation optimisation, I think, on the right path. We're now looking at how we actually realise the value that we're providing to Navy. Yeah. Capability optimisation. Again, we're looking at the capabilities that we offer Navy, and we're looking at what we need to continue to offer that also supports our people when they finally go back to sea. What I don't want to do is train people up in skill sets that they're not going to use at sea, because they'll just atrophy, they'll become out of date, and it's just not worth training them for that. I want to train people to increase their skill sets and ability so that when they go to the sea, they understand the equipment and systems a lot better than when they came ashore the first time. Technical mastery upskilling. Officer Milligan mentioned about training. We're looking, when we're upskilling our people, whether it's project management, I'll give you an example, we had a Killick bosun who we did a secondment with Thales, and he's now qualified in project management, and he's actually doing an outstanding job. So where we can give qualifications, we're looking to do that, and we'll be in discussions with TA Eng, etc., to make sure what we're doing is fully aligned with SHU is ripe for review. I think previous